dinosaurs. Right, here we are. Good evening, everybody. Chris F.E. Jackson here. Now, I haven't done one of these for a while. I'd seen quite a few bits and pieces, but they really are pushing the stories. And again, my favourite source of information, the BBC. Here we have Science and Environment again by Angus Davison, a science reporter. He's a science reporter. He's not a scientist. He's a reporter of science. So what he's doing is he's actually reporting what's out there in the mainstream, if you can call it that. So, being human. Big toe clung on to longest primate origins. Here we have a nice picture of 2 feet of a young person, most probably. And scientists have found that our big toe was one of the last parts of the foot to evolve. A study suggests. So look, big toes, last thing to evolve. So I wonder what what it was before it evolved into a big toe. A thumb? I don't know. Okay, let's continue. As our early ancestors began to walk on 2 legs, right, they would also have hung about in trees, using their feet to grasp at branches. Now, how do they know that? The only reason they know that is because primates today, we actually have species that do, like spider monkeys. They use their tail, in fact. What are they going to say next? That we had tails and they clung onto the branches? So if our big toe evolved from not hanging onto a branch, perhaps we had a tail that just disappeared. But they're concentrating on the big toe. Okay. They walk differently on the ground. Like a bit difficult because me big toe's sticking out. But we're still able to move around efficiently. A bit like apes, like chimpanzees. They can still run a bit on their hind legs. And that's where they get this idea from, most probably. The rigid big toe that eventually evolved gives efficient push-off power during walking and running. Yes, thank heavens for that. The findings have been published in the journal Proceedings of the National Academy of Sciences. Now, I did take a look at that. I don't usually look at this sort of thing, but I did. I'll get to that in a bit, but here we go. Look, a picture of a little forlorn chimpanzee. Oh, look, he's using his foot with his opposing thumb on his. Well, no, not opposing thumb. With his big toe, he's using his big toe to hold something in there. Well, he's looking at something there. Yeah, so you can see how that would grasp a branch or something. In this new study, scientists made 3D scans of the toe bone joints from living and fossil human relatives. I'll tell you what, I must admit, I'd love to if any of my relatives were fossils, it'd be interesting to see, wouldn't it? So I think they're using that in looser terms. Okay, including primates such as apes and monkeys, and then compared them to modern day humans. Well, let's just think about this for a minute. There's 2 sets of is it genomes or something that's missing that we don't have, which makes us completely different to these beings, these primates. We're completely different. But because they have 2 upper limbs and 2 lower limbs and a head, ears, eyes, nose, mouth, they assume that we've evolved from them. There's been no proof at all, is there, as we know. They overlaid this information onto an evolutionary tree, revealing the timing and sequence events that produced the human forefoot. Well, you produce it onto a tree, just by diagrammatically stating that, without any evidence. One goes on. Oh, here we are. The main finding is that the current shape of the bones in the big toe, or hallux, in anatomical language, must have evolved. It must have, people. It must have. So there, we're telling you. Must have evolved quite late in comparison with the rest of the bones that they investigated. Well, I wonder how they came to that derivation regarding. Well, that bone doesn't. Yeah, because it's these look a lot older. It's amazing what they can tell from fossils, isn't it? Oh, and why does it matter? In an interview with the BBC, lead author of the study, Dr. Peter Fernandez from Marquette University in Milwaukee, said, "Our ability to efficiently walk and run on 2 feet or be bipedal is a crucial feature that enabled humans to become what they are today. For everything to work together, the foot bones first had to evolve to accommodate the unique biomechanical demands of bipedalism." Well, you don't say. He then said, "The big toe is mechanically very important for walking. In our study, we showed that it did not reach its modern form until considerably later than the other toes." Well, that's where you need to show the proof. You say it's mechanically important, but then if I had chopped my big toe off, I'm sure I'm still be able to run. Let's continue. When asked whether the rigid toe evolved last because it is most or least important, Dr. Fernandez commented, "It might have been last because it was the hardest to change, because it was the biggest one, perhaps. We also think there was a compromise." A compromise? What? What, you mean like between the other toes and the big toe? "The big toe could still be used for grasping." Wow. "As our ancestors spent a fair amount of their time in the trees." Now, did they? Perhaps that's why there's no fossils, because we all spent our time in the trees. "Before becoming fully committed to walking on the ground." Right, okay. Well, perhaps up on the ground, up on the trees, in the trees, who knows? There's no real proof, is there? They're just surmising. In the trees, people, in the trees. We have primates that now live in the trees. We have primates that live on the ground. We have primates that live in hot springs. Perhaps we all lived in hot springs. Who knows? He's just saying perhaps. Perhaps. He added, "Modern humans have increased the stability of the joint to put the toe in an orientation that is useful for walking, but the foot is no longer dexterous like an ape." Aren't we fortunate, people? Aren't we so very fortunate? Oh, and look, there we go. Like, that's the modern day orangutan. Why, if evolution exists, he doesn't want to be in a tree. Maybe he wants to learn the secret of man's red flower. Who knows, right? Oh no, this just takes the biscuit, this bit. Why did early humans walk? Well, because they wanted to get to the next berry bush, or maybe they saw another female over there that they much preferred than this one, or a female much preferred a male from that one. There was, needs must, right? But here we go. The reason that our ancestors stood upright and then walked on 2 feet is still a mystery. Yes, still a mystery. It's a mystery why they did that, because you have no real idea about if we were living in trees or not. But there are plenty of ideas. I think I've just reeled off a few of my own, haven't I? Scientists think that walking may have evolved either because it freed our hands to carry tools, or because climate change led to a loss of forest. So climate change is finding its way in. Maybe they were burning all these fires with man's red flower that it filled the atmosphere full of carbon, and they'd gone through a climate change themselves, so they thought they'd better grow or arrange their big toes so they can walk to better climates, right? And find more food and forage for more food and stuff, Well, because of climate change led to the loss of forests. So they couldn't live in the trees anymore. Right, lads, can't live in the trees anymore. All the trees are dying. Better do something about our feet so we can move. Oh dear. All that overhead arms can be used to support walking on 2 legs along thin branches. Here we go, boys. Here we go. Studies such as this one show that early human ancestors must have been able to walk upright for millions of years, since the 4.4 million year old fossil Ardipithecus ramidus. I'll try saying that after a few more beers, I don't know. But that they did not fully transition to a modern walk until much later, perhaps in closer relatives with our own group, Homo. The Ardipithecus ramidus, there must be a different group then. This new study, alongside other work, now confirms that early walking humans, or hominins, still used their feet to grasp objects. So, there you go. So it's not quite, fully blown. Even though we're walking upright, we can still grab an apple with our foot. Or a nut, whatever. What has been the reaction? Okay, this is obviously the research. Dr. William Harcourt Smith from City University of New York, who was not involved in this study, said they are suggesting that one of the earliest hominins, Ardipithecus, was already adapting in a direction away from the predicted morphology of the last ancestor of chimps and modern humans, but not towards modern humans. To me, this implies that there were several lineages within hominins that were likely experimenting with bipedalism in different ways to each other. So, what do you mean? That some were trying with both legs, some were hopping, some were jumping? I don't know. How would you guess that they were experimenting? How would they know that they were experimenting? And it continues. Professor Fred Spoorer, an expert in human anatomy at the Natural History Museum, London, said, "It was a bit of a shock when hominins were found to have grasping or opposable big toe, as this was thought to be incompatible with effective bipedalism. Of course, this work shows that different parts of the foot can have different functions. Yes, when a big toe is opposable, you can still function properly as a biped." There you go, people. So, monkeys today, they can still have. So why, if you can bounder about on two feet, without opposable toes or offset toes, you can still get about. Why is it a function of evolution that they have to be straightened out? Oh, sorry, I did forget. They did tell us, actually, because of climate change. That's right. The last step. The scientists involved say that this work shows that early hominin feet had a mixed and versatile set of functions, like walking, grasping trees. Becoming human was not a giant step, no pun intended, right? But a series of gradual changes, with some of the last arguably most important changes being made to big toes. So it's the big toe, people. Big toe's the big problem. Hit the link. Peter Fernandez said that they would like to conduct similar analyses on the remaining bones of the forefoot in order to fully characterize the changes involved in the evolution of bipedal walking. So it's not foregone conclusion then, is it? So let's take a look at what they said. Let's go to the evolution. Let's go to this site where it says in the I do beg your pardon, in the proceedings, the PNAS, the Proceedings of the National Academy of Sciences. Okay, let's go over there. Let's have a look. Evolution and function of the hominin forefoot. Yes. Significance. Abstract. Let's take a look at the abstract. What they do say, yeah. I'm not going to bother reading this out because it is just gobbledygook. I mean, they do say that it does need further investigation. So you can read this at your leisure, because I'm not going to read it out. I think that's pretty much a done deal. So again, they're pushing this evolution, they're studying, and I did download some software where you can actually put in the raw data for the materials that he actually looked at, so you can actually model. And I think what it is, it's something to do with it's an Excel spreadsheet with some other forms or other, but I won't bore people with that stuff. Needless to say, this is what they're plugging out. And also, while we're at it, I'm going to go back to The other one, because what's actually happening now is they have the other. Winged reptiles thrive before dinos. I don't really know if I want to get into that. Oh, this one. This is good. This is good. This one. The Meg, the myth, the legend, the science, people, by Mary Holton, another science reporter. She's not a scientist. She's a reporter of science. So she talks to these people and she writes it down, and she passes it to Edison. And they put it out. There you go. She doesn't know it's right or wrong. She just says, I'm a science reporter. I just just talk to these people when I say what I ask a few questions and they tell me what it is. So I don't know, just put it in there. So anyway, we all know from the 70s, I remember seeing it myself, Jaws, 1975, or whenever it was, 77. Oh, cheers, by the way. I'm on some Guinness today. So, The Meg, apparently it's a new movie, and it's Hollywood's latest shark tale. It's opening wide this week in anticipation of summer audiences in the mood for a scare. Yes. Proposing that the extinct Megalodon, a large prehistoric relative of the great white shark, has survived to the present day. The film follows its subsequent encounter with humanity. Just like the Jurassic films, isn't it? It's all these dinosaurs. Look at everything that's kicked off for that, and then all the stuff they put out about it, and dinosaur this, dinosaur that. All Hollywood fiction, pretty much. And now, they're actually bringing out the Megalodon. So, they're called the Meg. Now everyone's going to be fantasizing about the big sharks. Oh, imagine this, imagine that. Oh, it's terrible. But they know all about these because they've got it all logged, and obviously I'm sure they were consultants to the film, just so they get it right. They can't be wrong, factually wrong in these films. So it says here, but how much do we really know about the giant predator? This is the thing that lived in the sea, and what impact do shark attack films have on their real subjects? Oh dear. Okay, here we go. Shark researcher and Megalodon expert Catalina Pimiento from Swansea University wants to break down a few myths, isn't it? I think that's a picture from the film. Some mouth there, and what she's wearing. Oh, look, some wings. Little wings. Megalodon is very much still alive in the Meg. More like Smeg to me, but there you go. No, I won't go into that. Dead or alive, it's very much extinct, says Dr. Pimiento. Well, thank you very much. There's no way it can still be around now, is it? No. Researchers have pinned the date of Megalodon's extinction at about 2.6 million years ago, roughly when its cousin, the great white shark, was just becoming established. Wow, isn't that a coincidence? So 2.6 million years ago, people. Wow, it's I just love these timelines. I love these timelines. In the Meg, the Megalodon has survived the ages in a previously unknown to humans, area of deep ocean off the coast of China. However, Dr. Pimiento points out that Megalodon likely lived in water no more than 200 meters deep, in and around coastal areas. Well, that has to be an assumption, surely. We would, she says, have noticed something of Megalodon size if it was swimming off our shores. Well, I guess we would, wouldn't it? But it's not around, is it? What did it look like? Much of what we know about the species come from its teeth, which are some of the only remains that have been preserved. Right, so you get a tooth, you build a big monster. Just like the dinosaurs. You find a little bone like this, or bone like that, and you make a ginormous creature out of it, with skin and stripes and killing everything. So how big was Megalodon? Here we go. Here's a picture. Oh look, Megalodon, 16 to 18 meters. Notice how they make it look like a shark. They make it look like a giant shark. You know, here's a diver, 1.75 meters, great white shark, 5 meters, megalodon, 16 to 18 meters. Well, maybe these giant sharks were around when there was giant people as well. So to the giant people, these sharks, or these megalodons you call them, just look like normal sharks, really. Estimates of its full body length range from at least 13 meters up to a maximum of 18, or almost the length of 2 double-decker buses. While this dwarfs great white sharks, it's not quite the submarine crunching 25 meters featured in The Meg, which is the film. It's called The Meg, the film, right? Now, what did it eat? Megalodon's remarkable size is fascinating to researchers, as an animal that large would have had to work very hard to find enough food. Very hard to find food. Well, if it was like a shark, it would just do what a shark thing does, but only on a bigger scale, right? If you think about that on land, for example, all the largest animals are herbivores. Yeah, they eat plants and stuff, yeah. If you're that big, then you need to eat a lot of prey, and you need to hunt a lot of food. So you need to hunt a lot to find that much food, explains Dr. Pimiento. Well, surely herbivores, if they're that big, actually need to eat a lot of food, you know, to maintain, you know, keep grazing all the time. But predators, if they're that large, only need to eat once in a while, because once they do get a large prey to eat, it sustains them for quite a while. So they won't be munching on food all day, every day, will they? A bit like the normal world now, the natural world now. But I digress slightly. Oh look, they show a human with a whale. Modern whale sharks can go up to megalodon's length of 80 meters, but only eat plankton. Yes. Well, I suppose they're eating all the time. So that's why megalodon is so amazing, because it was a predator and it was huge. So there, you've been told. Just watch the film The Meg. It tells you all about it in there. Although it's very difficult to know much about how megalodon would have moved and behaved, Dr. Biendu has her suspicions about what kind of hunter it would have been. She hopes to build a 3D model of the shark in order to study this in more detail. So build a 3D model of a shark, all based on what? Information from a tooth? So if this is the size of the tooth, and I compare it to a shark's tooth, then this one must have been humongous. It could have just been a big-mouthed shark, couldn't it, really? I mean, that evolved a bigger mouth with bigger teeth to actually prey a bit more efficiently, perhaps, you know? But no, they connected with size and, you know, big, and millions of years ago, and died out, and climate change, and volcanoes, and evolution, and so on and so on. Jack and Ori, innit? There we go. So that's it. You know. Yeah. So if I had to guess, I wouldn't think it was an agile predator. I think this is Dr. Pimiento still carrying on. It could even have been more of a scavenger. Sharks are opportunistic, and they will eat anything they can. If they can hunt, they will hunt. If they see a carcass, they will eat a carcass. Yes. So even if we had lived at the same time, a small human snack might have been not worth the energy. I see. So here we are. It's a picture of teeth. They say the 3 largest teeth come from megalodon, the others from shark species. But what we don't get here is a scale. How do I know that this is a megalodon? Because these could be coming from anything. Which one's the great white? I don't know. This could be the great white, couldn't it, really? But they're saying these 3 big ones are the megalodons. To what scale are these? They always take these pictures in very close proximity to make the effect of it being large, people. Yes. Why did it die out now? Here we go. Is that climate change, perhaps? I don't know. Living in the sea, climate change? I don't know. There's no evidence that megalodon's remarkable size was the cause of its extinction, but food was almost certainly a factor. Right, okay. Rapidly changing sea levels about 2.6 million years ago impacted the coastal ecosystem that the giant shark inhabited. Well, why didn't he just swim away then into deeper waters? Because obviously when man suffered from climate change, he was able to grow a big toe and walk away, come down from the trees and adapt, You would have thought that Megalodon may have adapted, thinking, whoa, it's getting a bit shallow and warm here, nothing around here, perhaps I should move back a bit over there, swim over there. Oh, look, there's some food there. Oh, but, so who's to say? Yeah, so 2.6 million years ago impacted the coastal ecosystem that the giant shark inhabited. As if it was true, as it's a fact here, people. They're stating it as if it's a fact. Megalodon was the last of his lineage of giant sharks. So there were more than just Megalodons, and there was other giant sharks then, was there? And it was succeeded by smaller, more agile hunters like the great white. All publicity is good publicity. Although the Megs creators put a good deal of research into reviving Megalodon, as if it was a real thing and they're reviving it. Get it, people? They're reviving it. They're not. It's just it's Hollywood. It's Hollywood, and they're just backing up the, oh look, the scientists say that this is good, so we can make a film about it. We've got license to make it a bit more scary, Before adding some artistic license, not as if you're adding artistic license to your description of what happened millions of years ago. Previous shark attack films have been thought to affect their real life counterparts. That's right. We know the film Jaws affected the shark species themselves because people would go out and they would hunt sharks. People would assume that the sharks were bad, but we need sharks in the environment to maintain the balance of natural order, the way the place was designed to be. Movies have had such an impact, says Dr. Miento. Yes, for one time I agree. We shouldn't take them lightly. Jaws had a huge impact on the protection of sharks and a role in giving them a bad reputation. Yes, people don't realise how vulnerable they are. That's true. It was speculated that shark populations off the US coast were affected after Steven Spielberg's 1975 blockbuster, 77 or 75, I don't know, with fishers setting out to catch trophy sharks. I do remember that, yeah. Nowadays, sharks are threatened by human encroachment on their hunting grounds, competing for the same prey. Yes, I kind of agree with that. Yep, it's always man that is the problem. If Megalodon had survived to encounter humans, it's likely we'd be far the greater danger. Well, perhaps. But the far greater danger at the moment is you lot spouting all this rubbish and rhetoric. So, with that, I shall end on that. And again, I couldn't resist these two, I'm afraid. Okay, right, thanks for watching, people. And I'm going to carry on with my beer now. So, good night, everyone. Hope everyone's well. Bye for now.